Okay, so what we're going to do is now look at an example of a problem that you'll be getting for homework. All right, and so the idea with this problem here is that we have a population of finches, and the finches have two beak colors. So we have some beaks are black and some beaks are yellow. And what we know is that black is completely dominant to yellow. There's no incomplete dominance like we saw in that flower example before, so we don't necessarily know what individuals are heterozygous because they're going to look they're going to have the black beak. And what we find out is that in this population of, let's say we took a sample within the population, so not every single individual, but we take 500 as our sample, and in that 500 we find that 45 have a yellow beak. All right. So the other 455 are black-beaked. And so now you're going to have a bunch of questions. Questions are going to be related to, what's the frequency of the recessive allele? What's the frequency of the dominant allele? What's the frequency of the different genotypes? And one of our simple questions is, in these individuals that are black-beaked, do we know how many are homozygous, dominant, and heterozygous? So how many are dominant, heterozygous, and how many are dominant, recessive, like this, because they're both gonna look in appearance or phenotype black-beaked. So we'll take the Hardy-Weinberg equation and see what we can do with this, all right? So based on what we know already, what do we have? Okay, so we have yellow beaks, all right? We have yellow beaks, and that's a genotype, right? So that's going to be the genotype little b, little b. We know there's 45 individuals. So that's 45 individuals out of a population of 500. So that's going to be 45 divided by 500, and it's going to be 0.09, right, as a frequency for BB, like that. And so BB is also equal to our yellow phenotype, that's Q squared. So what we want to know is, what's the frequency of just the allele of Q here, or just the B allele, just the yellow allele? How much? So how do we find that out? Well, if 0.09 is Q squared, what is Q? Q is the square root of this number. So B equals then the square root of 0.09. Or again, it's Q, here, but we're using B. This is for the yellow allele. The square root of 0.09 is, and I had to work this out because my calculator is my camera, which is also my phone, is 0.03. Okay? Now, we know this. Okay, so remember this. That's the one version of the Hardy-Weinberg equation with the genotypes, right? What about the alleles? So we have, remember this equation? P plus Q equals 1. So now B is Q, right? So that means that we have P, that's going to be the dominant allele, the B, plus Q, which we now know is not 0.03, it's 0.3. Equals 1, so that means that P equals 1 minus 0.3, so P is going to be 0.7. So 0.7 plus 0.3 equals 1. So now we have the frequency of the black allele. It's 0.7. So now we can come over here and say, oh, okay. All right, so B is equal to P squared. That's what that's representing, right? The dominant allele, the homozygous individuals, right? And so that means that's 0.7 times 0.7. So that's going to be 0.49. So that's our p squared. Plus p squared plus 2pq plus q squared. Well, we already know q squared is 0.09. If you remember, this whole thing has to equal, 1. And so our 2pq, a couple ways of doing it. One is you could just add these together and subtract, or we could multiply, these out, and we can say, oh, okay, so it is p, which is 0.7, times q, which is 0.3, times 2, that's 2pq, right? If we do that, we get 0.41. And I think there's a little rounding, error when I did this, so we're off, by a little bit. So it doesn't add up to exactly 1, it's like 0.99. So yes, so we can figure this out. So we have essentially, 9% of the population who have the yellow beaks. We have 41% of the population with a black beak, but they're heterozygous, and we have 49% of the population with black beaks that are homozygous, dominant for the black beak. So you can figure this out, and you should be able to then use this. What you're using, you're using like fairly simple math here. You're just kind of adding these numbers up to 1 or finding the difference from 1, essentially. And the main thing you have to do is sometimes take a square root, of one of the numbers to go in the other direction if you're given the phenotype, which you didn't convert into a genotype. But you should be able to solve a whole variety of different types of problems with these two basic equations, with the p plus q equals 1 and the p squared plus 2pq plus q squared equals 1, and then just be given some information about a population. So you're given phenotypes of some of the individuals. You might be given the genotypes instead. You might be given a whole variety of different things, and asked, what's the allele frequency, what's the genotype frequency, and so on. And you should be able to then work these all out. So that's going to be, then your assignment is to work out a bunch of problems and figure it out. So you might hit a couple stumbling points, but you should be able to do that.